Okay, so now we have our two equations and our two unknowns. We're going to go ahead and rewrite these equations out so that we have them written in such a way that we can see what we have. Okay, so I'm going to go ahead and write it here. I have force on block by rope 1 cosine theta 1 is equal to force on block by rope 2 cosine theta 2. That's my first equation. And my second equation is force on block by rope 1 sine theta 1 plus force on block by rope 2 sine theta 2 minus mg is equal to 0 newtons. Okay, so those are my two equations. Now what I'm going to do is I'm going to go ahead and solve, well, there's several ways we could do this. We could divide one equation by another. I'm not sure that that's going to work for us for right now. So what I'm going to do is I'm going to solve for force on block by rope 1 by dividing both sides by cosine theta, and then I'm going to substitute that in here. So I end up with force on block by rope 1 is equal to force on block by rope 2 cosine theta 2 divided by cosine theta 1. Okay, now what I'm going to do is I'm going to substitute this into this equation here. So I have force on block by rope 2 cosine theta 2 divided by cosine theta 1 times sine theta 1 plus force on block by rope 2 sine theta 2 minus mg equals 0 newtons. Okay, now I can factor out a force on block by rope. So I end up with force on block by rope 2 times, I'm going to go ahead and simplify this. Sine theta 1 divided by cosine theta 1 is just tan theta. So I'm going to make this cosine theta 2 tangent theta 1 plus sine theta 2. And then I'm going to bring this over to the other side, so because I am trying to solve for the force on block by rope. So now I'm going to divide both sides by this factor. And I end up with force on block by rope 2 is equal to mg divided by cosine theta 2 tangent theta 1 plus sine theta 2. Okay, and that is the magnitude. The direction, this is force on block by rope 2. The direction is going to be 30 degrees north of west. Okay, so the direction is going to be 30.0 degrees north of west. So now I have my magnitude and my direction. Now we're ready to solve for force on block by rope 1. We're just going to go ahead and substitute in here for force on block by rope 2. Okay, so, and I already have it solved right here. So I'm just going to go ahead and substitute in here. So I have force on block by rope 1 is equal to, here I've divided both sides by cosine theta 1 already. So now I'm going to substitute this in for here. Okay, so I end up with mg cosine theta 2. Okay, there's the mg, there's the cosine theta 2, divided by cosine theta 1 times the cosine theta 2 tan theta 1 plus sine theta 2. Okay, and what is the direction of this one? This one is going to be 50.0 degrees northeast. Okay, so there's my magnitude and my direction. Okay, we should really technically have been writing here force on block by earth, because that's actually what we're being given. But this mg is the same thing, and it's a lot easier to write mg. Just remember, though, that if you're substituting in numbers, that you are not going to substitute in 55 newtons for the m. Okay, this entire thing is the 55 newtons. Okay, so at this point, you can substitute in the numbers and solve for your unknown. Again, making sure you're not putting 55 in for m, because the numbers they give you are for the weight of the block. See here? It says 55 newtons, not 55 kilograms. Okay, this is the weight of the sign. Okay, so you can go ahead and numerically solve for that answer. I'm not going to do that. To me, that's just the math part of it. The physics part is coming up with these equations.